Hello everyone, my name is Daryl. I work as a software developer, and in this video you'll see how I naturally work through a LeetCode challenge. This is a problem that I'm seeing for the first time, and I'll explain myself as I work through it. My solution won't likely be the best or most efficient. It'll be the one I come up with first as I'm working through the problem. So this is another medium difficulty question here on LeetCode. This is number 8 on the website, string to integer, a to I. So it says, implement the myA2I string s function, which converts a string to a 32-bit signed integer similar to C or C++'s a2I function. The algorithm for my a2I string s is as follows. 1. Read in and ignore any leading white space. 2. Check if the next character, if not already at the end of the string, is minus or plus. Read this character in if it is either. This determines the final result if the final result is negative or positive respectively. Assume the result is positive if neither is present. Read in next the characters until the next non-digit character or the end of the input is reached. The rest of the string is ignored. Convert these digits to an integer. So 123 goes to 123, 0032 goes to 32. If no digits were read, then the integer is 0. Change the sign as necessary from step 2. If the integer is out of the 32-bit signed range, then clamp the integer so it remains at the range. Specifically, integers less than that should be clamped to that, and integers greater than that should be clamped to that. Okay, return the integer as the final result. Note, only the space character space here is considered a white space character. Do not ignore any characters other than the leading white space or the rest of the string after the digits. Do not ignore any characters other than leading white space or the rest of the string after the digits. So first example, 42 goes to 42, and so they show step by step here. Okay, so they're showing step by step by step, and it's going to be returning as a 42. This one, basically it's getting rid of the leading white space. It's returning it as a negative. And then you have s, which is equal to 4193 with words, and it outputs 4193. And that's because it's going to ignore anything that's an invalid character after it starts getting the numbers, okay? So the length is going to be between 0 and 200. And s is going to consist of English characters, lower and uppercase, digits 0 through 9, space, plus, minus, and dot. This is an integer, so a dot is essentially an invalid character. Okay, so one thing I like about this question is that in a way it seems a little bit easier than most of these questions because they kind of lay out literally the steps that you should go through in your algorithm here. Whereas, of course, in most of these questions, you have to figure this stuff out yourself. So we should be able to basically go step by step here and get this done. So let's copy this over, and we'll start with step 1. So we get this string, and we need to remove leading white space characters. So I'm going to make a work string, set that equal to s. So this is going to be the string that I'm working with, and then we can just say work string equal to move leading white space work string. So this is going to be a new function here. And actually, yeah, that's fine. And we want to return a string. And we want to make this a bar. For now, just so we don't get compiler errors, we'll return 0. Oops. Okay, so we're going to kind of just do these steps and do it, separate them out into functions so that it's easy to kind of see step by step. If something goes wrong, it'll be much easier to figure this out. So in this case, all we're going to need to do is return s.trim. And so this will automatically trim down. It'll get rid of the white space in front of and behind that the string. Yeah, we can make it private, that's fine. Even though this is something very simple like this, I am putting it as a function because of these steps and the way it's kind of laid out. I like having this, I think this is more readable, you know, that we're doing step by step by step. In my actual code, I probably would just do s.trim, but I like having it showing that this is step 1 and we're doing step 1 right here. I just want to try this here real quick. There you go. And then I'm just making an extension function here. We can actually change it to this, and we can say this.trim. When thinking about readability, I think this makes even more sense. So we're just kind of adding this function onto string, and we can do workstring.remove leading whitespace. For step 2, we're essentially either finding if we have a negative or positive, and if we don't have a negative or positive, then expect that it is positive. So we'll have a val is positive equals, let's do workstring.retrieve sign, and we'll make that here. And we're going to return, or actually I think this would, so the reason why I'm changing my mind on this is because it's going to be doing two things, and I don't like the idea of it doing two things. I don't want to remove the sign from the work string and get the value back. It's doing too many things in one function. So instead, we'll just figure this out in here. I think that'll make more sense. So I'm just going to set is positive. Let's make this first char. And then we'll just say if first char is equal to negative. Gotta do this. So first char is negative. Well, now we'll have a val is positive is equal to true. And we'll say here is positive is equal to false. And we gotta make it a var. So we're going to expect that it's true. If it's a plus, then this will be true. If it's not a plus, it'll take it as true, true as in it being positive. We just need to say, hey, is there a negative? If so, then make sure we set it that it's negative. So that was step 2, almost step 2. We need to remove the character if it's either or. So let's do another thing here. If first char is equal to that, or first char is equal to that, then we want to say workstring.remove drop 1. We want to drop the first value. Now we're on to step 3. So we're going to basically keep reading characters until we reach a non-digit character or the end of the input. Let's do a while. Let's actually do it for character in workstring. Let's have a remove at index, set that equal to -1, and so just say if character, we can say if character is not a digit, then remove at index is equal to, well, we're going to need to make sure we have the index character with index, set it equal to index, and then break out of the loop. We'll keep this together just because this is part of the same step. If remove at index is not equal to -1, then we'll do workstring.drop last, and the amount is going to be workstring.length minus remove at index plus 1. Because, so for example, if the first 4 characters are numbers, then our remove at index, actually it'll be fine. So get rid of the plus 1. So because if we had four, the first four characters were numbers, remove at index would be 4 because it would be the fifth one it would detect that it's not, and it would remove it. Okay. So now we are moving on to, we should now have work string as just the number. Then we're going to convert these digits to an integer. Really quickly, I'm just going to check the S could be 200 long. Okay. All right. So now we are on step 4. So we're going to convert the digits to an integer. We're going to say result int is equal to 0 at the start. And then we're going to loop through. We're just going to loop through character in workstring.reversed. So we're going to reverse it. And so at the start here, we're going to say also that the multiplier is equal to 1. And what we're actually going to do, let's have actually this be work long. And this is going to be a long. So the reason why I'm using a long is I want to make sure. So I'm going to do something special to check for extraordinarily long values to make sure that they're, to clamp it down to the range kind of a thing. But in case our value is a reasonable length, but it's still above or below these values, we want to make sure that we can store it properly before I detect that it's outside the range. So I'm going to use a long, which is a 64-bit integer in Kotlin. So we're doing this reverse so we can keep it easy with the multiplier, because then we can start with the lowest one and keep going up. And we're going to say work long is equal to, I think it's safe to use character.toInt or too long. You just do too long. I think it's safe to use character.to. I don't think this is cheating, basically, because I know in a way you're converting a character to a long. But if I was to implement this manually, all I would be doing is creating a switch statement where if the character is a 0, then I'd return a 0. If the character was a 1, I'd return a 1, and so on and so forth. And I don't think that at this point using a cast to long for a character is cheating in this. So I'm going to go ahead and use that. And we're actually just going to say plus equals that times the multiplier. And multiply itself by 10. Now, one thing we want to check for, I think, actually, I'm going to do this slightly out of order because they're having you convert it here and then checking the range. But I think you want to check the range beforehand. I think what you want to do is once you have the work string here, I want to say that if workstring.length is greater than 10, because so the smallest value it can be is 2,147,483,648, and then the same on the positive side, which is of length 10. So if the length is greater than 10 at this point, we know it's out of the range. So then we just want to say if is positive in this case, then all you want to do is return the maximum value, which is 2,147,483,648. Okay, I don't know why it wants me to do 2 ints there. That's kind of silly. And I don't think that's cheating because it's specifying that's an int. Else return negative that value.toInt, and then I guess you can lift that out of there. Okay, so this. Okay, 1 second. All right. Really interesting that it doesn't want it to be 8. Maybe it does. Because it should be the 48 here to 47 at max. Okay. So this is we're going to do the clamping right here, basically. And so this will return, Because at that point, we know it's too large in one direction or the other. But if it's not too large, then we're going to get here. Then we should have the value. We still need to check if it's outside the range, though. So once again, we don't have the positive or negative slapped on it, so we can just say if, since it's a long, we can simply say work long is greater than this value, return this value, and we'll be able to lift the return out of here. Else, if work long is, actually we can just, we don't need to have this there. We can just do it here. If work long is less than, actually, okay. Now if it's greater than that and is positive, then return that. If work long is greater than this and not as positive, then return this value. All right. Now we can just do return. We need to do that real quick. So if not as positive, and we're going to have bar results is equal to work long to int. And once again, I don't think it's cheating to cast an int to a long, so we're still doing all the work here. I'm sure you guys will say this stuff is cheating, but I really don't think it is because I'm doing all the work. I'm just casting a long to an int at the end here. So if it's not positive, then we want to say results is equal to negative results. Then either way, we return results. And apparently we can make this a val, so let's go ahead and do that. Let's go ahead and try this. I am sure there's going to be something wrong with this. Actually, just copy the whole solution. Just going to run their example. Okay. Well, we definitely got something wrong going on because we got 42. So let's do print. And this is going to be solution.myatoi, and we're going to pass 42. And so I'm just going to run this. Oh, that's fine. I just wanted to inline it. All right. So let's go ahead and run this just to make sure we get the same results. And then I'll go through these steps here and see what went wrong. So yep, we got that. So I'm going to go ahead and debug. So here we got where, I didn't expect that to do anything. So this step is setting the is positive. So let's kind of go through there. So is positive is true. First char is 4, which is fine. And S is still 42. Then this next step, we're going to read in the characters, which this should end up being 42. So S is still 42. This is not going to happen. That's the clamping. This part is the part where we are actually converting it. I think I know why. Because character has the wrong value. Let's do get the numeric value and cast that to a long. Let's just hit play. 42. Okay. That's looking better. Let's try that. That should work with their example. And I'm sure one of these extreme cases is going to not work properly. And we'll have to probably debug that, but let's take a look. Okay, so this one, let's go ahead and test how that works. Okay, we're gonna debug. So, okay, well, right away it didn't remove the leading white space. So that's definitely going to be a problem. We forgot to include chars. Let's go ahead and run that. Okay, we still get the wrong answer, but let's take a look. We debug. We still don't. You just take a look real quick. All right. Let's just go through, find these S's, turning them into work strings. Maybe that's it. So now if I hit play, all right, well, let's look at what's going on here. All right, so you still got the negative there. So let's get through here. So is positive is false, that's correct. The drop didn't work, so let's do... You can't do that. So let's do... place drop 1, and we just want to say work string is equal to that. All right. How about now? Okay, it's still something weird, so we're going to go through it again. So now we got the proper work string, and we still have its negative. Okay, after that point, that was removing extra characters, but we didn't have any extra characters. That's not going to do anything. Now we're going to have our work long. Aha. This needs to be work string. Now we got negative 42. All right. Now let's copy this over. Run code. Submit. Okay. So we got something wrong with this string. Let's figure this one out. Make sure we get the same results. We basically, I can tell basically with that number we're saying we got too big of a result, but let's go through it. Okay. That was fine. That's fine. Okay, so it's setting remove at index to 4. Okay. Breaking out. And it's not negative 1. So, okay, so this is because we got to do work string is equal to work string dot drop last. How about now? Now it works properly. Okay. Run code. Submit. We got a string index out of bounds exception. If you pass in, okay, it sounds like an edge case to me. If you, so if s dot length is equal to 0, or it's empty, that's what that equivalently is, then just return 0. That should be fine. That's an edge case. Okay. It doesn't like this one. You know, I don't think we ever removed the leading zeros. Let me confirm that, though, before I actually make any changes. I think that's what's going to be the issue with this one. Yeah, it's 18. All right. Let's remove leading white space. I think we need to have a remove leading zeros. Yeah, because we're like working with that. Okay. So let's go ahead and do that. Workstring.remove leading zeros. So we're going to need to make this. Okay, be able to do return this dot trim start for zeros. So now we go here. If we go here, actually, that's a good question. Okay, so we got to do this, and I have to say work string is equal to work string. All right, let's try this now. Boom, look at that. All right, so now we hit play. That is correct. All right, let's see if there's any other issues. Okay. All right. How about this? This check if it's empty, how about we put that after we remove the white spaces and the zeros? I think that'll fix that issue. Still doesn't like that one. It's saying index out of exception, index out of bounds exception. So let's try that. So we remove all that stuff, and then right now it's completely, we shouldn't be checking S, we should be checking work string. That's why. Now if I hit play, I bet we'll get 0. Yep. All right. Try that. Okay. Obviously that should be a -1. Okay, interesting. I'm gonna have to add another remove the leading zeros after you check if it's, yeah, because I see what the problem is with this one. Let's see if that returns the right answer. Yep, that's -1. Okay. So after you remove the negative sign, just do another remove the extra zeros. I think there's still going to be another problem. Okay, so this one should return a -12. Let's see where this one goes wrong. I need to actually put a debug statement. Okay. Okay, and yeah, so then I remove the zeros. Okay, so remove at index is equal to 2. It's going to break. And then it's going to drop the last characters. Work string became blank. Because, once again, this needs to be work string. And that factoring that I did really destroyed this. Or when I let it change it to just use S instead of work string. That caused so much havoc. And of course it would have been nice to do just a string replace, but considering it was S, that was going to be not fun. Alright. I output -42 for that. Isn't that what it should have? Oh. I think it's saying that in this case, I just want to see what we're getting to. We got to 1080. We are almost there. So I think so it's because the zeros were first. Let's see what the problem is. Let's do a quick check here to say if this value 0 is not equal to that. The idea is that I'm trying to see if we remove the leading zeros and then the next value is a negative sign. Let's see if that helps. That might break something else, but I just want to give that a shot. Okay, so that breaks the blank one. Okay, so I think we do need to do a check here. And we need to do okay, so if that length is greater than 0 or is not empty, then if the first value is not that, and I know I'm running that function a few times here. Just trying to see if this helps. Okay, so that works. So it looks like it's showing that it's not a particularly good answer. And I'm sure it's not just because I ran this function a couple of times here. The memory usage is probably because I used a long. That's going to be my guess. Is that you could have done it some other way. And the runtime I'm not particularly sure. There's probably some tricks to make this go faster. But I think this worked out pretty well. So let's go ahead and go over this code real quick. So first we get in our string. Then we're going to run remove leading white space, which goes ahead and removes any spaces from the front and from the back, actually. We could actually change that to trim start, which probably would be very slightly more efficient, but not enough to actually change much. Then we're going to check after removing white space, is the string empty? Actually, we want to do trim so that this works. So if the string is empty at that point, then just go ahead and return 0. If there's still something there, then we're going to check. First, if we remove leading zeros, is it going to still have values in it? So remove leading zeros just trims the start from zeros. So is that not empty? If that's not empty, then we can do this check to say, hey, is the first value after removing the zeros at the front a negative sign? And so if it's not, then we'll go ahead and remove the leading zeros. Otherwise, we want to leave them as they are. And then after that, we'll just go ahead and check, because we could have removed leading zeros. If it was all zeros, then it would be empty, and we can go ahead and just return 0. Next, we're going to go ahead and continue, and we're going to figure out now if it's positive. So basically, we're going to assume that it's positive, and then we're going to get the first character. If it's negative, then we're going to set is positive to false. And then either way, we're going to check if the first character is a negative or positive. Then we're going to go ahead and remove it from the string. Then we're going to remove the leading zeros after that, because there could be additional zeros after the plus or minus sign. Then we want to see if we can find if there's any extra characters, because we want to only return the integer up until there's an invalid character. So we're going to go try to find the index at which we start having bad characters. So we're going to loop through and say, is this a digit? Is this a digit? And it's going to keep going until either it gets to the end of the work string and it'll just exit and leave this as a -1, or it'll go ahead and find the index where the issues start to happen, where we find a character that's not allowed. And then we're going to break out of that. And we're going to say, so if the remove at index is -1, we're not going to do anything. But if it is not -1, if it's something else, then we want to take the work string and drop the last characters. Basically, we're dropping from where we start having those issues. So the work string's length minus the index that we're at, that those issues started at. That's going to get us the length that we need to drop. So that drops the end characters that we don't want. Then we want to go ahead and check if the value is widely out of scope, right? Because this is going to be an integer. So this is the max value it can return. This is the lowest value. So these are both of length 10, not including the negative sign because we removed it. So if the length is greater than 10, then if it's positive, then we're going to go ahead and clamp it to the top value. If it's not positive, then we're going to clamp it to the biggest negative value and return that. Otherwise, we're going to go ahead and continue. We're going to use a long here because even though we did this check back here, this next step could result in something that's over this value or under this value, just less than adding, another digit to that length. And then we're going to set multiplier to 1 because we're going to step through the string backwards. That's what this reverse is doing. And so we're going to add to this work long the numeric value of the character, casting it to a long, times the multiplier, which will start at 1 because we're going to be at the first digit because we're going backwards. And then we're going to set the multiplier to times 10 because we're going to the next digit. And we'll just keep going through that until we finish all the digits. Then we're going to check again here if we're going over or under. So is the work long greater than this value and positive? If so, then return that. Because the negative value is technically 1 higher, just in the other direction, we want to do a separate check to say, is the work long greater than that, and it's not positive, then we'll go ahead and return the negative clamp value. Otherwise, we just need to set results to the work long that we had, casting that to an int. And if the value is not positive, then we will go ahead and make it negative, and then we'll return the result. And now that I'm thinking about it, I'm sure that this is a not good solution because I'm sure that there are a bunch of people who went ahead and submitted this by literally just casting it to an int. And it's probably, the solutions are probably being diluted with those, which are probably way faster. Anyways, I think this is a pretty good solution. So that's going to be it for this one. Thanks you guys for watching. Hopefully it helped you guys out. Catch you guys next time.